Hi, everybody. I'm Anna Kopyto, Chair of Association of Polish Engineers in Great Britain. I'd like to welcome you all and say how very pleased I am to see that so many people have joined us for the first of the two panel discussions planned for today, opening our 3-day Congress of Polish Engineers in the UK, marking 80 years of Association of Polish Engineers in Great Britain. Some of you here may know Stowarzyszenie Techników Polskich w Wielkiej Brytanii quite well, but I'm sure there's a few people here who just got to know us recently, and so feel free to write a message in the chat. I will be very curious to know how did you hear about us and what made you join this session. If you have any questions, you can send them via chat or ask them later during our Q&A session at the end of the meeting. A few words about our organization. We are registered in the Charity Commission as a charitable incorporated organization. We are a professional affiliate in Engineering Council. And what makes it special is that we are the only national minority organization in the UK to ever achieve that. Our mission is to build and maintain strong relationships with Polish engineers and technicians who live and work in the UK, provide them with mentoring and support in career development, as well as promote broadly defined science by organizing conferences, webinars, and events like this Congress. If you would like to become a member, please visit our website, stpuk.org, to register. We welcome people who would like to engage themselves in running this organization with us and make it more attractive and interesting to existing and new members. Our headquarters are located in the Polish Social and Cultural Association building, POSC, at King Street. Nearest tube station is Ravenscourt Park on the District Line. We will be there tonight from 6 p.m. So if anyone would like to join us to participate in the second panel discussion from there, please feel free to pay us a visit. Our office is located on the 3rd floor. We are a non-profit organization run by volunteers. So I would like to express my gratitude to the sponsors of this event: Embassy of the Republic of Poland in London, Fundacja Grabowskiego, Stowarzyszenie Polskich Kombatantów, and Polonia Aid Foundation Trust. We're very grateful for your continued support. Without a further ado, I would like to hand over to Dr. Agnieszka Knoppik-Jędrzejewska, Assistant Professor at Department of Structural Engineering at Silesian University of Technology, who will be the moderator of the first discussion, Making Sense of It All: How to Gain Insight from Data. Enjoy listening. Agnieszka, over to you.
Thank you, Anna. So, hello, everyone. Good afternoon. It is a great pleasure to be able to moderate this interesting session, and thank you for inviting me to participate in this Congress. It is very close to my heart as I live and come from Poland. So thank you once again. As it has been said by Anna, so far the topic of this panel discussion is about how to gain insight from data. So we know that we all live in the world of data. People have used data ever since they started to exist on Earth, and they were using their intelligence to retrieve information from this data and make decisions. First of all, in their everyday life, but soon they started to use it in their professional activities. However, it is important to say that at the beginning, the analysis of data was very implicit and people have used their intuition or experience to analyze and manage data. And at this point, I would like to take a liberty of quoting one of our excellent panelists who has made me aware of the fact that according to this survey made by McKinsey Global Institute, the data-driven organizations, so the organizations that use management and analysis of data, are 23 times more likely to acquire customers, 6 times as likely to retain those customers, and 19 times as likely to be profitable as a result. And this should already give you some insight of why it is important nowadays to use data. So when we think about data, I think a lot of us who do not work with data professionally thinks about big databases, which are analyzed statistically for the purpose of research, engineering, or business. But nowadays, with access to fast machines, fast computers, and new technologies such as artificial intelligence, we are able to work with different types of data, not only structured data, not only and not necessarily numbers, but different types of data that can help in our everyday life and also in our professional life, regardless of the branch where we work. That's why I would like to present you today 3 excellent panelists who will try to shed some light into how we can use, manage, analyze data in these different branches. So from the side of engineering and industry, we'll have Balazs Haraszti, who is a senior BIM manager and digital engineering lead on the RDP schemes of Skanska. Balazs is experienced in digital delivery from various types of projects, which include both buildings and infrastructures, and deployed 5-dimensional and 4-dimensional workflows alongside with lean modeling techniques. Balazs is a strong advocate of digital integration of design, cost, carbon program, and construction within and outside of Skanska, and as he said about himself. From the side of business, we have Michalis Michael, who is a CEO at DMR. It's a tech company in AI-driven insight. By academic background, Michalis is an aerospace engineer, and by profession, he's a thought leader on unstructured data, customer insight, and customer experience measurement. And finally, to have a broader look on the topic, we have Professor Aleksandra Przegalińska, who is the Vice Rector of Kozminski University, where she currently holds a position of the Associate Professor at the Department of Management in Digital and Networked Societies. She is also a research fellow in the American Institute of Economic Research, as well as the Labor and Work-Life Program at Harvard University. Aleksandra received her doctorate in the field of philosophy of artificial intelligence, and she's interested especially in the development of new technologies, natural language processing, humanoid artificial intelligence, social robots, and wearable technologies. So as you see, very exciting topics from very broad range of activities in which we can deal with data. And I would like to start this discussion by a little extended introduction of the panelists, which I believe they can make themselves right now. So I suggest that we start with Michalis. If you could please tell a few words about yourself and how do you deal with data in your professional life?
Thank you, Agnieszka. So I'm usually based in London, but I'm calling in from Vienna today, and I'm originally from Cyprus. But I have spent a fair amount of time in Poland. I was in Warsaw for 8 years. So our world is about customer data. And I want to use this, the wisdom pyramid, as it is called. It is slightly adjusted to reflect our times. But I want to explain our world using this pyramid. So at the bottom, we have data. In the traditional pyramid, we have data, then information, knowledge, and then wisdom. In this adjusted pyramid, to take into account what is going on nowadays, at the bottom, we have big data, and that's anything above, gigabytes all the way up to exabytes of data, which is not useful at all on its own. And most of it is unstructured. So over 95% of all the data that was ever produced by humanity and recorded is unstructured data, which means text, audio, images, maybe video. Structured data would be the rest, which is numbers in tables. And so if you have 1 million tweets about Siemens, let's say, as an example, what can you do with that information? Well, the only way to know what's in that data is to read 1 million tweets, which is, not a good use of anybody's time. And so what we do is we take unstructured data, mostly text, and we add intelligence. So that's the second level. Intelligent data is when we annotate the text in whichever language it might be. AI can do that these days. So we can train custom machine learning models to annotate for sentiment, for what is the subject these customers or people are talking about in their interactions on social media, or writing an email to a company, or chatting with an organization on their website, all these different, or even calling their call center. So the first order of business in this day and age is to add some intelligence. What are they talking about, and how do they feel about what they talk about? And then in order for this to become information, we need to start consolidating and quantifying the intelligent data. So for example, we would, to use Siemens again as an example, an engineering company, so you guys will relate to that. So one could say 50% of all the tweets about Siemens are positive and 20% are negative. That's what I would call information. And then it becomes knowledge when you start adding some more context to it. And so to continue with the same example, I would say, so the 50% of those tweets, those 1 million tweets that are positive about Siemens, most of them talk about their innovative ways that they have introduced in their electronics or whatever devices they sell. And then someone needs to turn this knowledge into wisdom. And in our world, we use different words for wisdom. We use insight and foresight. There's also hindsight, but that's not so interesting. Foresight is about predicting, being able to predict the future. We talk about predictive analytics. And of course, insight is something that a company can take now and action and produce and create some benefit for the organization. So I will finish by saying that all these data that is now suddenly available to us to explore and understand, the unstructured data, that's only possible because of AI and because machine learning is helping us shortcut the exploration and the understanding of these huge data sets that are out there. Thank you.
Thank you very much. So please, let's move to Balazs. Hello.
Good afternoon, everybody. I'm Balazs Haraszti. I'm a senior BIM manager at Skanska and currently the digital lead on the RDP framework. So RDP framework is an infrastructure project, and by the nature of the construction and most of it infrastructure is really information based. We less focus on data. It's very traditional. We have set of deliverables, what we need to produce day to day, week to week, month to month, year to year. in order to satisfy the client requirements. What we really need to keep in mind is that when we talk about information or when we talk about data, these reports, what we're producing, these documents, models, pictures, visuals, this is just the top of the iceberg in terms of identifying or satisfying requirements for the project. But when we look behind the skins and see what's going on behind the skins, it becomes really obvious that everybody is dealing with data. We cannot live without data. That's the foundation of everything what we're doing. However, those people are not necessarily interested in or aware of the data and data structures what we're supposed to use on projects. So I'm starting with this first slide because it's just it wasn't me who put together this diagram, by the way, so please don't ask questions about how I produced it. But I think it nicely representing the chaotic status we have in construction in terms of different stakeholders creating their own data sets, focusing on information delivery instead of data delivery. And the relationship among these stakeholders are just complete madness. In a way, it's been exchanged with each other. So people focusing on creating reports, people focusing on their own stuff when they delivering the different documents to the clients, or even within the organization, handing over information between two different functions. So it's really a key to understand that all of us working with data, and we should be more aware of the data we're producing for the project and for the business. If you go to the next slide, please. So the only way to kind of take control back over this chaotic status we have in construction, and generally it applies to the entire construction industry, is to put some system in there, making sure that the data we produce will be useful for others. And we need to move away from the reporting and transactional approach, what we generally have in construction, and make sure that we set up the process, the procedures, we set up the correct workflows to manage information on construction projects. So in the core of everything, there's always the client requirements, the actual solution development, which starts with setting up a budget, creating an idea, what we need to deliver for that budget. And around that, there are loads of different functions you need to communicate with each other. The only way to put this in order is to linearize the process and understanding relationship among these functions. So starting with the top of the circle, it's key to set up a work breakdown structure for the project, which will enable the team to understand how we actually doing this work. Then we need to put the right sequence in place, making sure we have a plan of how we want to deliver the project. Then we need to assign resources, we need to find the right subcontract for the project in order to deliver the work. Then we need to start working on the plans, we need to start working on models and visualization to engage people. And then we need to make sure the quality of this information we're producing is satisfying for the other functions as well. So again, I'm using the word information there for delivery, as this is the traditional way of exchanging information with each other. However, we really need to focus on the data, a common data model to be established on projects, and that data model can feed live reports on the schemes that will support in the later stages to integrate the work of the different functions with each other. As we going around this circle, it's kind of setting up a sequence of the main functions, the main deliverables, what we're producing on projects. And in the very end of it, you can see one point there called automate, which is more like about, Michalis talked about previously, the wisdom, the insight and the foresight of the data, making sure we're taking the lessons learned on board making sure that the information we produce is always improving, having better quality day to day. And on the next projects or the next week of the same project, we will be better in delivering the information to the participants. We shouldn't forget that data we're producing is useful for others. We need to remove all the duplicated efforts from the project. We need to improve efficiency in construction in order to make more sense. Let's use the word we're using in the title of the panel, which basically enables the team to, rather than focusing on report production, reports more should become a snapshot of the current information we have on the project, and we should be able to generate it at any point of time when the client or stakeholders requesting it. If we go to the next slide, please. So this is what the construction industry now call common data environment. So common data environment is generally equalized with the document management system in construction, where everybody is talking about how we dealing with incoming information, how we dealing with outgoing information. But we need to see the whole picture and how the different functions working, what kind of systems they're using across the whole infrastructure project. As you can see, each box basically representing a function on the scheme. So we have information management in the core as it's essential to deliver information to clients and stakeholders. However, we have loads of other functions who's feeding into this information management process and producing their own data. All these data produced in different systems. These systems need to be configured in the right way and need to implement a common coding structure, which will enable the team to exchange data with each other instead of exchanging information. So this graph is really just showing a small portion of the common data environment, what we generally have on all the construction projects, in terms of having a document management system such as ProjectWise or SharePoint or Viewpoint. We have planning systems such as Primavera P6 or Tylos or Alice and other planning software. Estimators working generally in Candy or working in any other estimating systems. And all these different systems need to work together and form a common data environment in the end, which will enable the project team to deliver the project efficiently.
Okay,
thank you.
Thank you, Balazs, for presenting us your side of the story. So if we could ask now Aleksandra to present her background, and maybe you are already able to relate somehow to what has been said previously.
Mm-hmm. Yeah, sure. Thank you so much. So I was already nicely introduced. I am indeed the Vice Rector of Kozminski University in Warsaw, Poland, and also a head of the Human-Machine Interaction Research Center there, and also the leader of a program for bachelor students that is called AI and Management. And actually in that program, we deal with data quite a lot because it is the fuel for business. Surely it is the fuel to build competitive strategies, but it's also a fuel for good collaborations and good exchanges. So indeed, data is at the heart of our interests over there. And I think, which is also funny, I'm also connecting from Vienna, even though I'm based in Warsaw normally. So we're both in Vienna. Hi, Michalis, probably in different places. I wanted to come back maybe to the topics, of this very broad and robust relationship between artificial intelligence and big data. And data per se, that's kind of interesting, I think. When we look at AI today, there are a few trends that I think we can see that are really shaped by the kinds of data we're getting and the kinds of usages for data that we can find while we process them with artificial intelligence. So AI today is definitely something we can say is real, is serious, and becomes a very natural practice sort of, or a toolkit for medium-sized entrepreneurs, for small businesses, for big organizations, obviously, as well. And that, I think, is a crucial thing, that we have opulence of data, and we also have kind of more interest on all sides, different agents, to really make use of that data using machine learning, using supervised techniques, unsupervised techniques, using reinforcement learning whenever that's applicable. So AI became very real, I think, in the course of the past few years, not only as a scientific discipline, but also as a business practice and organizational practice per se, because we can think about NGOs and institutions using AI for different purposes as well. Predictive source, definitely that's something that I think organizations look into particularly. They want predictive analytics, they want to understand the world granularly, but they also want to make predictions about the future. And here AI obviously is an amazing resource. So I think one thing that could be said about AI today is that it's becoming something more specialized. We don't have one AI that serves many different processes. We have different types of machine learning solutions for different types of industries. AI is developing in logistics, it's developing in transportation, in healthcare, in retail, in finance, in education, in the legal sector even. And for all of these different domains, there's obviously a plethora of different questions that they wish to ask to the world, right? Because obviously they have their own interests. When you think about the questions that you would ask, and let's say a machine learning model in agriculture, these questions will be very different from the questions that you would ask if you're in the legal sector and you want to compile on or compare, for instance, certain documents, or make a comprehensive report of a certain legislation line that was provided in a given country. So I think we have more specialized artificial intelligence in the context of industries, but also in the context of the type of data that it operates on. We currently have structured, unstructured data, we have audio data, we have textual data, and plenty of that. Quite obviously, unstructured text is the foundation of internet as we know it. But we also have image data streaming from everywhere, and we also have sensor data, right? And IoT here is obviously a very important technology, also a general purpose technology that is parallel to artificial intelligence, that is also developing rapidly. And the real-time data from sensors is also something that AI can operate on, can process, and it provides an additional context for artificial intelligence, because real-time data is definitely different from historical data. And that's, I think, a crucial difference that is currently being explored, for instance, in industry 4.0. So the specialization according to types of data, but also types of usages for data in different sectors is, I think, something we're currently definitely seeing. Now, another thing that I would like to mention that's perhaps interesting is that the way in which we process data is also, sorry. Can you see me now? Yeah, all right. The way we process data currently is definitely also changing. So there are different thresholds of operations. You can be a very skillful data scientist, you can be a machine learning specialist, you can be a deep learning architect, and your skill set will be very advanced, and your ways of data processing will be also very advanced. But if you are a business leader, and my school, Kozminski University, is essentially a school for future business leaders from the region, but not only, then you want to make use of data as well, and you want to be data savvy. However, you will not reach certain level of competence, obviously, without well, I guess really carving out some time for that. So if you do want to use the data and you want to apply AI, but you don't have that big skill set that comes to you while you're studying, let's say, computer science, you may choose a different path. And that's yet another important thing, because together with AI specialization and AI mainstreaming, we also have certain degree of simplification. I, for instance, work in the field of natural language processing, natural language understanding, and here we work mainly with text. But I have to tell you that over the course of the past few years, I've observed how data processing has changed, how certain application, let's say, of data, and how building, for instance, machine learning models is simplified currently. You don't have to be a coder, you don't have to code. You can still build a model using drag and drop tools. You can use conversational AI, a very simple interface to really process various types of textual data. You can do a sentiment analysis. You can run different types of, NLP processes without coding. And that's one other important thing. And you can particularly, I think, observe that in NLP because, well, as I said, text is a rich resource. It's an important resource also for business, and business looks for insights, about their products, their services from textual data mainly, although not only. And thus, I do see a big change, right? How we can currently use conversational AI, how we can use very, I would say, complex algorithms like transformers, but they are presented to us with a very friendly interface. So anybody who disposes of textual data, be it unstructured, structured, whatever, can actually today make a use of it without any complex knowledge, at least on the basic level. So this simplification and specialization, I think, are very important things. And that shows us how pluralistic sort of ML or AI are as methodologies for data handling, and certain prospects also into the future. We as a team also focus in our research work on collaborative AI, so the type of AI that works with people, and we particularly focus here on managers. And we indeed, in our experiments, are trying to track how, for instance, marketers, people who not necessarily have the background in data science, can use the power of AI, for instance, to do a better customer segmentation. And they're using those very friendly interfaces to process textual data, but very often also image data. Transformers, as probably many of you know, are those types of algorithms that can handle both image and audio, and can compose music and can generate text and can analyze text. So their application is very, very wide. And what is more, that interface to apply them is also becoming more simple. So I do think at this intersection of AI and big data, we currently have very interesting processes that allow us to make AI and advanced data processing a more mainstream sort of activity. And that's something I wanted to bring up to our discussion. Thank you.
Thank you very much for your quick introduction and the introduction of all of you. So when we were listening to your, let's say, presentations, I think there are two expressions that were being repeated a lot of times: big data and artificial intelligence, which says that we have now tools to manage data. And in the meantime, I also have a question in the QA, so I would like to channelize a little bit this discussion, because you mentioned a lot of different branches, a lot of different locations where you can use data and these new technologies in data management. But let's keep in mind that we are now in the panel session that is mostly being participated by people from science and technology, so different specialists in engineering, so people who work in companies that are specializing in science and technology. And I believe that those people, or we, would like to know how we can better use the data in our business, so to make our business more, let's say, better answering the needs of customers from one point, but also, as the question here is, how to become more sustainable. And I would like to start this discussion by asking you if you can point out the types of data that could be used by such specialists to achieve this goal, because you mentioned a lot of different types of data, but I don't think that all of them would be, let's say, useful for them on the same level. So where do you think they should start? So what data would be useful for people who work in science and technology, but from the business point of view?
I can go first.
Yes, of course. Now it's an open discussion.
So in our world, we separate data into 3 or 4 buckets, but the main ones are: there is behavioral data, so the facts. What did they buy, the customers? What websites did they visit? What did they like? What did they share? That's facts. And then we have the customer opinion, which we divide into 2 buckets. The solicited customer opinion, which is when we send surveys and do focus groups. So when we ask questions and they answer, that's a big chunk. But probably the biggest, which comes from social media and online posts, is the unsolicited customer opinion, which is when they give us their opinion about our organizations, brands, and products without asking them on Twitter, on Facebook, on Instagram, and so on. And yes, there is also sensor data, so IoT, which it's huge, and in our world we don't deal that much with it. We focus mainly on customer data, opinion, and behavior.
Okay, thank you. Some other insights.
I can add. So what is kind of an interesting, I would say, collision of different types of data in our scientific work. Perhaps not per se in engineering, but maybe it will be interesting at least to some of you. So what we do as a science team is we're trying to gather both textual data. For instance, if we're optimizing a chatbot, very often our team is designing different bots for different purposes, research purposes, but also applied. And thus, when we want to optimize the bot's performance, very often we run experiments where we gather a lot of conversational logs, so textual data, unstructured text mostly, of different kinds, but then we can label it and then work on its quality. And we confront that with physiological data. And physiological data actually is the data that comes from sensors of different kinds. For instance, if we want to detect certain psychophysiological states of people, heart rate, the response of their facial muscles, frowning, smiling, or for instance, let's say data like EEG, so data from the electroencephalographer. These are very interesting sources of information about certain, let's say, affective mode of a human being. And obviously these data are very interesting. They're you have to like kind of process them very carefully, and you have to be very diligent, and also they're sensitive. So that's something that is important to say. I think, the ethical aspect here matters quite a lot. We're talking about sustainability, but ethics is a big deal here. But for us, when you clean that data properly, when you work with that data, and when you can isolate, which stimulus actually creates a certain effective response, then that becomes a very rich source of, let's say, ambient intelligence that we are getting. And we can understand, let's say we were talking behavioral data, we can understand sort of behavior in a more complex manner. So I think combining different sources of data with this, certain mindset that you really need to take care of them in a different way, but then try to correlate them at some point, can be a very, very interesting source of insight. At least that has been our experience. And I think, I've touched upon the issue because that relates hopefully to your question also here, let's say quality of data. So when we think about insights and generating insights, for me, the first thing to think about is not really sources or types of data, but whether that's quality data, right? Whether that data is representative of a certain phenomenon, whether the data is, diverse, whether the data is robust enough and wide enough. And if we focus on this in the first place, on the practice of really having quality data, I understand that that's not always the case. And sometimes we don't have the comfort of gathering quality data, but that should always be our attempt and our best practice, I think. And thus, to me, that's the baseline, right? Really, I mean, if I'm running an experiment, I want to make sure that we have enough and that whatever we have collected is good. And only then I think the experiment, whatever data sources it takes into consideration, is considered to be something that is truly diligent.
Okay, but do you have any special methodology to assess what data is the quality data?
You're asking me or others? At this point,
I think it's
well, I mean, first of all, I mean, in our case, yes. I mean, obviously, first of all, we have to have enough study participants. If we have to have enough sort of conversational pool in order to make sure that quantifiably it's sort of enough to even make any kinds of distinctions. The length of this conversation also has to be, somehow verified in terms of it not being too short, because then we cannot run sentiment analysis that we would consider really solid, right? I mean, then the data becomes a bit of a mess. So we have certain, let's say, aspect when it comes to textual data that allows us to assess whether it's, internally broad enough. The other thing when it comes to physiological data, the assessment of quality obviously comes from the fact that you often collide different types of sensors here, different types of physiological responses, because if you just isolate one, this will not be enough to run an experiment, right? If you just have, let's say, heart rate, for instance, and nothing else, then that's probably not going to speak to you. But if you have a whole physiological panel, right, then you can perhaps assess something in a much more reliable way. So obviously you can come up with more measurements. You can think about how that data has been collected, to what extent that data is clean, to what extent don't have certain, holes in the data that can, well, ring a bell, I guess, here, that you have not collected them in a continuous manner. And therefore, well, in physiology that does happen. You cannot really make any inferences out of that data. But I do think that, in that particular context, richness comes also from collecting data from different stimuli here, and also from different kind of sources of bodily responses. So to me, obviously, I think that's going to differ for different industries, for different protocols and whatnot. But to me, these would be sort of the criteria, one of the criteria in our experiments.
I see, thank you. And if we can have Balazs, because I think that your experience is the closest, let's say, to our participants, and I have a lot of questions directed to you. So if you could share some insight about the data you deal with. So what data these are mostly, how you know they are good data?
Yes, thank you. So I think in the construction industry, as mentioned, it's more traditional. So by the nature of engineers, we would like to know how things work. So we hardly believe anything which we don't fully understand. And that's why probably AI is not necessarily, and big data is not necessarily utilized in all the different parts of construction. It turns out, here and there, to be utilized for urgent development of information. But as we are engineers, we would like to understand everything what we're doing, and just machine spitting out information on the other end might not convince us that the information is reliable. So in construction, the focus is more on the quality of the data we're producing, similar to what Aleksandra just mentioned. So we want to make sure that the information and data what we receive from the different functions are actually up for the standard what we established before we start any construction works on the project, or even starting any design works on the project. So we need to make sure that we're setting up data models, we're setting up data structures and requirements for the different functions. We're setting up templates and libraries to supplement this process, and we kind of monitoring and controlling the process during the whole life cycle of the construction projects, making sure that everybody is comply with these requirements, everybody using the templates and utilizing the libraries to create information.
Okay, thank you. So I have a nice question that popped up in QA from the audience, and it's a general question. So whoever feels comfortable, please answer. So how the data is being used in risk assessment process to identify common and unknown risks to improve existing processes. So using data in risk assessment. So I think it's an important topic.
So in our world, the companies come to us, for example, banks, and their risk is the organizations to which they lend money. And so from social media posts that can be harvested in millions of posts in any language, like I said before, they can do what they call a commercial due diligence to see if any of the organizations that owe the money, if there are any red flags that may predict problems in the future that will hinder them from paying their loan installments. That's just one example of risk assessment. Same idea is when companies acquire other companies, or funds or private equity acquires companies. Part of the due diligence is to find out if there are any red flags, and social media posts and any other online posts are a great source. And again, that's text or images or video or audio sometimes, and AI is very helpful to tell them, to make it easy to find the red flags that they're looking for and reduce risk.
I can try and add one more example to that of a completely different type of risk assessment that I've been involved in. Actually, I've worked with the Warsaw Polytechnical School on a project related to risk assessment on construction sites. And actually, it was an interesting project because we've used the various types of wearable technologies, for instance, installed in helmets, or in the gear of workers who are on construction sites, and for instance, on heights also. And obviously here, what you're doing is you're trying to figure out whether the current state of a given person, their position, wherever they're finding themselves, but also sometimes also medical parameters, if everything is okay, to make sure that, you can track if the situation gets out of control. And that was an interesting project because it allowed us to really survey different types of wearable technologies that are specific already now for construction sites, including cameras, but also physiological sensors like the ones that I've mentioned before. And here, based on this type of sensor data, that is again real-time data, when you add that to a predictive model, you can actually, what you're reaching is a certain predictive maintenance, right, for a construction site when you're looking for potential problems, right, or rather perhaps for certain regularities in order to prevent, any type of risky situation on construction site in the future. So here I understand that it's a completely different type of question. We've also worked as a team with a bank for loan prediction, and that was a sort of risk assessment related activity, very hard one, by the way. But I do think that risk assessment is such a broad sort of problem that perhaps it's good also to mention those unobvious sources of data that can really serve better maintenance in places that perhaps are not directly related to artificial intelligence. And the construction sites seem to be kind of on the rise in terms of their interest with IoT data.
Yes, definitely. That was very interesting example. Thank you. And if we could come back to this topic, the question that was asked at the beginning, because I think it was not, let's say, fully discussed. So the problem of sustainability. I think this is one of the biggest issues that are dealt now with the companies who are engaged in engineering. So if you are engaged into something that is connected with industry, I think sustainability is one of the issues that is most problematic nowadays. So the question was how to use data to support this sustainability agenda.
I can start if it's okay. So yeah. Regarding sustainability, it's a very popular topic now in construction, and everybody is kind of for carbon values and carbon footprint projects leaving behind, which is really part of the legacy of any schemes we're working on. In terms of the sustainability, I think it's quite a big topic, and probably we could have another panel discussion only on the sustainability. But it's really a teamwork which is required for identifying the right legacy or right sustainable solution for the scheme development. As sustainability really starts from the beginning of the supply chain and ending up through the construction, we're ending up with a full life cycle and maintenance operation parts of the assets. So we really need to kind of consider the whole journey of a product, going from the manufacturer to the site, handing over to the operation, to the operational team, who's actually maintaining it and eventually replacing it. So data is really useful when we identifying, okay, we have a piece of product there. It comes with a manufacturing sustainability value, what we measure usually in carbon, and that product needs to be delivered to site. The site team need to build it, which we have like a massive resource involvement in terms of trucks, plants we're using, the different the journey of the human resource to site, the equipments we're using, the fuel we're using. So there are many different components in there, and the only way to manage it if we understand each piece of this process. So in construction, it's slightly connecting to the previous question related to the risk management, which in construction, it's also really experience-based. So people who worked on previous projects have a good understanding and a good intent to identify potential risks on the project, which includes both the threats and opportunities of the schemes to either improve or avoid issues. And this is really important when we apply that to the sustainability as well. So when we identify the product we want to use, it needs to come with a standard data set attached to that product to support the process of initial manufacturing details. And then the company need to have their own assessment of how much added value we produce when we deliver it to site, when we installing it, and eventually when operational team replacing it.
Yeah, thank you for your insights. I don't know if other panelists would like to ask.
Yeah, maybe I will add something from a completely different angle, because I think, as Balazs said, sustainability is such a broad thing, and reaching sustainability, well, there are many pathways to it, I'd say. And one thing that I think preoccupies us quite a lot, and I saw that it was also asked in the chat, it was, sources of data. But when we think about sources of data, about collecting data, we can also think about recycling data and reusing data and using data and sharing data. And I think sharing data is something that perhaps prevents excessive, need to really constantly try and generate it from different sources. I, for instance, quite recently encountered, let's say a term that to many of you may be familiar, and I started exploring it, and that's data trusts. So different types of consortia that can be built by private entities, institutions, but also public institutions to release data for a common goal, so that everybody can exchange that data, so that people, for instance, who have a similar problem or similar domain can use your data to train, for instance, their models. And I do think that this is something that is not enough explored, particularly, for instance, when we think about the European context. In Europe, because of privacy issues, because of various regulations that are out here, we don't have like a flow of data everywhere, but perhaps that's for the good. But also in terms of like still experienced by particularly smaller companies, certain data scarcities, right? I do think that this data trust concept is related to sustainability, to sustainable development goals in terms of creating platforms for sharing, for exchanging, and also in a sense is something that allows us to reduce certain types of activities and focus on others. And I know this concept is very much explored today in various domains, particularly for public data. That seems to be only a natural solution. But when you think about private data and entities that would like to have a greater data pool, but perhaps it's also something that both is sustainable and is something that is a workable solution for them. So just wanted to throw that into our discussion when we talk about sustainability and data.
Aleksandra just reminded me of an interesting case of data that has been released in the UK by the Department of Transport. Just a quick example. So they released all the train ticket prices from all possible combinations in the UK, and it was millions, if not billions, of ticket prices. And so we were part of an R&D project, and we were supposed to analyze and find out and listen to what curious things we discovered, which was basically bad for the public. So as an example, a route from London to Glasgow, there were 240 different prices that you could find, and they ranged, register this, from £7. So if you were smart enough, like hackish kind of a person, you could buy a ticket for £7 and go from London to Glasgow. And then on the other side, you know, all the way up to £500-600 for exactly the same distance. So releasing data for the common good is a very interesting notion, which is what the Department of Transportation did in that case. And I want to believe that after our R&D, these problems were improved. And so now that, you know, it's easy and transparent to find 2 or 3 types of tickets from London to Glasgow and know why one is more expensive than the other, and not a range from £7 to £600.
Yes, thank you for that. So it was nice that you raised this topic, because there is indeed a discussion going on in parallel in the chat about about owning data. So who owns the data? How the access to the data should be controlled? You have already expressed some of your opinions. Maybe you would like to add something to that.
I think this is an interesting question. So who's owning the data? Who has the intelligent property of managing it and controlling it? Each of the organization who's producing information need to eventually hand it over to other organizations, and mostly it's managed via the contracts and legal people to set the scope for the work of the subcontracts, and making sure that we're going to get covered from legal perspective, that we can use information coming from other organizations, and they're responsible handing over information to us which complies with the standards.
Any other comments on this topic?
Well, I just say that really it's kind of important to stress, and I think that resonates well here with the panel, that we as societies are also co-owners of many types of data, and there is an obligation, for instance, on the side of various institutions to release data. And that data can be something that is additional to our, let's say, processes, whatever it is that we're doing, but it can also serve as its core. It can serve as a core for various types of educational activities where you want to teach people how to work with real data, right? I mean, to have data sets available for that, but also for different types of processes. Like I think we're very often forgetting in the world of business where, you know, many people kind of guard their data. Data is that fuel, data is king. Maybe in the future it won't be. Maybe in the future, you know, the power of novel algorithms will be that core that you compete with, and not the abundance of data, because data will be abundant. But I have the impression that we tend to forget every now and then that there are many kind of open data sets that are released, and also that there is an obligation on the side of the state, for instance, and institutions to release data. And that's something we can quite often also demand, for instance, for different types of things. So I like Michalis, your example here, because that's exactly what's being done here. And yeah, I think obviously the response here varies, but in many cases, we are all the co-owners of certain data types. And if they're fruitful, if they can help us, we should have access to them.
Yeah. So someone in the chat said there are 2 types of data: the ones the organization owns, and so only the organization knows about, and the ones that are in the public domain, like in my word, social media. But there's a third there's a third bucket, which is, and there's a business around that. So there are aggregators of data who go and pay data owners for their data. So one example from my industry is Nielsen or Information Resources, which are multinational market research companies. They pay retailers to give them the sales data from the point of sales of each and every product they sell in their supermarkets. And then they take it from all the retail chains, Tesco, Sainsbury's, Waitrose, if we want to talk about UK retailers, and they aggregate it and they sell it to the manufacturers, to P&G, to Coca-Cola, to Unilever, so that they can see what is their market share in Tesco, Sainsbury's, Waitrose, and what is the price. So there's this third category, which is aggregators who buy and then sell data as well.
I will perhaps complement briefly. In that context, third type of data, for instance, I am quite aware that banks that cannot own certain types of data or have access because of various regulations to certain types of data are buying from such aggregators. For instance, aggregated, pseudonymized, quite often data stemming from social media platforms, or your usage of the mobile phone, or whether you logged in from your home Wi-Fi or elsewhere to kind of model the behavior. So indeed, aggregators are quite often out there, and there are many ways in which you can purchase or get data from them.
So yes, indeed, I think that the data owning is a difficult topic. So as Aleksandra said, a lot of companies guard the data and they use it as a market leverage, for now at least. But also we have this second world of public domain where data are made public for greater good. And we know that a lot of open source initiatives work like that very well and even are able to make a profit of publicly available data. But this leads us to another problem that was also raised by Aleksandra. So you said that in the near future, the AI algorithms will be more important than data. And here comes the question how AI can become a threat to data, for example, to our identity, or what are the other risks for data with this smart, let's say, technologies.
Okay, but I have to clarify. I didn't say that that's going to happen. It was just my speculation. I don't know where and that's going to happen. I don't know how, but I'm trying to envisage a world, according to a paradigm where data is no longer the king, sort of. And I'm wondering what would happen next. And if you compete against others, if you're looking for your unfair advantage, where would it be? And my speculation was that maybe somewhere in the hardware, maybe in the algorithmics, maybe in the way you process information. I don't know, quantum computing. So it was just like an open, speculation. I'm not betting all the horses on that yet.
I think it is a really good point that worth mentioned that AI already exists and it's already been utilized in various parts of the different businesses around the globe. In terms of construction, we see AI appearing here and there, and it's a really good tool when it works. But I have to add that every time when we're seeing an output from an AI solution, it goes through on various assessments to make sure that the information is actually produced is reliable. So as mentioned previously, we quite traditional in a way we approaching data, and we would like to understand how it's being produced, what kind of calculations are behind it. Otherwise, we just don't have trust, and where we don't have trust, we put it into the risk pot, and with all the risk, it needs to be assessed. It needs to be processed properly before we're utilizing it.
Yeah, well, there is a way to develop trust, but machine learning is sort of a black box. You don't know exactly how the model decided to annotate this tweet as positive or negative or neutral, but you can measure the accuracy of the model. So in other words, you can take 100 tweets about Siemens and read them through and annotate them for positive, negative, or neutral sentiment towards Siemens, and then see with how many you, the human, agrees with the what the model has done. And so if you agree with 80 out of 100, then we would call that 80% precision or accuracy, to use a more widely used word, but it's actually precision. There are three measures of accuracy in machine learning: precision, recall, and F-score, right? And that would be precision. But you don't really know exactly the workings in the black box.
Yes, similar to Aleksandra, I'm not kind of proposing here that we are not going to utilize AI in the future. That's not really the case. We need to build up the confidence simply. Like with any new technologies, people need to start using it, need to start testing it. And if we're going back to the accuracy of the information in the end, is when it reaches, let's say 99%, that's going to be the case when people get confidence in that information. Until we're reaching that point, it's just keep tested and tested. And in some cases, it will be helpful. It will be useful still with less accuracy in construction. But again, an assessment will always follow that process until it's get a reliable percentage.
Okay, so from what you're saying, we can basically imply now that safely to say the AI is now at this stage that is not, let's say, smart enough, but I can see that there are people who are worried that it will soon become smarter than we are. Do you really see it as a threat?
So I'm going to just try and respond very briefly, because I will need to say goodbye to all of you.
Okay.
And thank you for the panel. But I'd say, like, really look into the, for those interested, look into the concept of collaborative AI, where the assumption is actually that we never stop being the, sort of guards of artificial intelligence, and rather we focus on how it can help us, then release it to do certain things instead of us or on our behalf. And frankly speaking, this model is, I think, more down to earth, because this is what actually is happening. We are the architects, we are the selectioners, we are the ones who are really, setting goals for artificial intelligence. And I don't think that's going to change anytime soon. Obviously, there are certain threats that are related to AI, but if we focus on this sort of collaborative AI, if we treat artificial intelligence as an augmentation to our skill set and a help in certain processes where we want it, right? And maybe we allow for a certain greater degree of explainability, which is a big problem on its own, but we can work with that. That I do think that that builds a safer pathway, perhaps a better pathway, in which we can bridge our best competences with artificial intelligence and have it as an element of our decision making and not the decision maker. And to me, that's kind of, I think, normatively speaking, kind of an important statement that we just, don't let it get ahead of us, but rather focus on how to make best use for us, out of it.
I think it's important to make the distinction between strong AI, which is what Agnieszka is implying or asking. It's not smart enough. Well, yeah, it's not strong AI yet, but weak AI or narrow AI is pretty good, right? So we can train AI to accurately annotate for sentiment Chinese, 1 million Weibo posts in Chinese without knowing how to speak Chinese. So it does a perfect job of that one little job. Strong AI is defined as something else, right? We're talking about consciousness. We're talking about, chatting with a machine without realizing it's a machine. That's something that some people say it may never happen. Some people say by the end of this century. Some people say, the optimists, in the next 10 years, but who knows?
But do you think that we are now at this stage that some standardization should be introduced into the application of AI to manage it, let's say, legally, ethically? Are we at this stage?
I think definitely not, in my opinion. So I think AI is an experimental at the moment, and we need to leave it to kind of grow on its own without too much regulation. So let's get people to play with it. Let's get to the stage when it's actually, as Michalis mentioned, that improving quality of the information, it's splitting out in the other end. And when we get to the point and we continuously keeping an eye on this, and when it's get to the point that we are producing information which is very, very accurate, then we need to start considering, okay, what kind of regulations we need to put on this without stopping the development of such solutions.
Well, I think we do need a legal framework and a moral framework, ethical framework, but those conversations have already started. If you Google these things, you will find that there are associations that are already thinking about these things, but it's not applicable yet. Only when strong AI happens, all these things will be applicable.
Okay, so to close the discussion panel, because we are reaching the point where we need to say goodbye, but last, let's say, funny question to wrap up the panel. What's the most fun project you worked on that based on data, and in what way it used data? There were some examples already, but
for me, it's we did something for Coca-Cola around a Super Bowl game. Super Bowl is this big match of American football in the US, and some people started saying negative things about the ad of Coca-Cola on social media, and then the rest of the world, who wasn't usually participating, they started attacking these people, calling them names and swearing at them, and we discovered this phenomenon of which we called the positive effect of negativity. So the positive effect of negativity in that case was because some idiots said something bad about Coca-Cola, the supporters, they felt like, usually they wouldn't post, but in this case they felt like they needed to stand up and defend whatever the brand that they liked.
Yeah, for me, always the current project is the most fun one. I think in construction, it's almost like a restart every time we're starting a new project, and we completely forget what happened before. However, challenges are the same. The fun part is the same, but working with data, I think, on newer and newer projects and enjoying what technology can do for us is always nice to see. If I'm looking back where we were in 10, 15 years ago when started to work in construction, or started to work in data analytics, or started to work in any other job really, you can see that okay, we used to go down to the corner to have a phone call with someone. Now the phone is out in our pocket. When we talking about information sharing, discussions, it all happens ad hoc, anytime anyone is available. So I think it's getting more and more fun, and with the new AI VR solutions, as it's getting used in construction now, mostly the augmented reality is the one what I'm thinking on. Is allowing people to kind of mixing up the information coming from this digital platform and the real world for the benefit of people.
Thank you very much. I wish we really had more time for this discussion. A lot of topic popped up, very interesting and also very troubling for the audience, as it seems. So I think that if someone is really interested in some specific issues, you have access to contact to our panelists, and I think I can encourage you to start this contact. And now I must give back the microphone, the voice to the chair to close up this session. So thank you once again.
Thank you, Agnieszka. Many thanks to all panelists for such an insightful discussion. I very much enjoyed it. And the digital age has generated an enormous amount of information, and certainly there will be immense benefit for those who see its value and learn to extract it and leverage it. Thank you to all participants as well for attending this panel discussion and for all the questions asked. And I hope to see you all again at 6:30 tonight for the second session, Engineering Over Borders. See you there. Thank you very much.